Hi, this is Robert Greer. This is Game Force NV5, Milestone 2. I'll start off with the project. So here's the project. It has the different libraries listed out here. Math, file, PCS. And then I have a new library called Manager, which is the standard manager base class with active and reserved nodes, as well as the linked list and delinks, which I'll use throughout the engine. So I'll start in the engine with the game objects. So a game object looks like this. It has it derives from PCS node because it's going to be part of a PCS tree. And then it has math objects using my math library to represent its transform. And then it also has a graphics object, which I'll get into soon. The game object can be attached to the game object manager, which has a PCS tree of objects, calling spawn object. And then when you call that, it just inserts the game object into the tree. And then the manager can be updated and drawn as a collective. So this will use the forward iterator over the PCS tree to update or draw all of the objects, as well as cleaning them all up or doing whatever you need to do. So that is how game objects are managed, and they can be built into a hierarchical structure where their world matrix will actually be updated based on their parent object and chained together, which we'll see in the demo. So another thing the game object has to be rendered is the graphics object. A graphics object looks like this. It's a combination of a mesh and a shader. Some of them also have textures as well. So the graphics object fulfills the render contract so that it can be rendered. And then when you render, it just does each of the steps to set itself up, draw, and then restore the state. For example, this one will activate its shader, activate the model, and then in draw, it just renders the model. So the different types used by the graphics object, we can go into those. So mesh looks like this. The mesh is basically just a bunch of buffers to describe the mesh. And I can go into one as an example. Here's the cross. It sets up a bunch of data and then sets up the DirectX buffers for that data. So it has position, color, texture coordinate, and normals. So the mesh is combined with the shader. So the shader allows the graphics object to activate the shader. And when it's created, it'll also create all the shaders through DirectX. So the derived implementations of this basically just describe the schema of that shader and what its data is going to be. And so then the last thing is the texture. So the texture object is just another type of object, and it is loaded from a file using that load from TGA file method from DirectX to create the textures. So each of these primitive graphics types are managed by their own manager. So we have the mesh manager, which is a standard manager base using that manager library. And that way you can reference meshes by name by just referencing them through the manager. Same thing with shaders. You have the shader object manager, which provides the same functionality to reference them by name. And then same for textures, texture object manager, same idea, referencing them by name. So those are the primitive graphics object types. And those are all used at the end of the day by the game object to render the different objects. And then another thing is the camera. So here's the camera class, which is mostly unchanged, except I added some methods to move it around. And then it's also managed by the camera manager, which is another manager base. And it has a current camera. And you can get and set the current camera. That way I can switch between different cameras and have global access to the current camera when I'm rendering. So that is all of the tools to make the demo. Now I can go into the game class where the demo is set up. So starting off in load content, I load some different cameras with different initial positions into the camera manager, and then I can switch between them at runtime by calling set current camera. I load up my meshes into the mesh manager, so I have 4 different ones: cube, pyramid, diamond, and cross. I load up my shaders into the shader manager, which I have 4 different. I have color by vertex, flat texture, light texture, and const color, which is a wireframe. And then I have the textures, which are loaded by name again, and they're associated with a texture TGA file. And then throughout the demo, I'll use all these to spawn game objects by calling game object manager spawn object, which basically just spawns the objects. I can give them a name. I give them a graphics object, which has a mesh, a shader, and then optionally a texture or light parameters. And then I can set the location, the color, and the scale. So throughout the demo, I just spawn a bunch of objects of different models, different shaders, different textures, and all that fun stuff, which I'll show when the game's running. And then in update, I just set various properties. I move the objects around, and I have controls to move the demo around, which I'll show. So that's basically the code. Now I'll jump into the demo. So I'll run and debug. Here's the demo. I can move the camera around with WASD. I can look around with the arrow keys. I can move up and down with space and shift. I can swap between cameras by pressing Y, U, I, and O. And that gives me some different options for the cameras. And then I can cycle between those to have different views. So I'll just go back to the first camera. So that's the camera manager. Next, for the models. So here's the 4 models: cross, cube, diamond, and pyramid. Then I have 4 different shaders. So here's the color by vertex shader. There's the wireframe const color shader. Here's the light texture shader. And then here is the flat texture shader. I also have 4 different textures, which you can see. And then on this one, I can swap the texture dynamically with V, B, N, and M, which is interesting. And then I also have instanced, so I can have the same model instanced several times, different shaders, different transforms, scales, whatever. And then I have movement. So here I have these cubes translating along each of the axes to demo translation. Over here I have the cross rotating, and then the boxes inherit the rotation, and then the pyramids inherit from the boxes, and that way you get the hierarchical movement. And then over here, same thing, I have the diamond rotating, and then the pyramids have their own internal rotation that gets built up on top of that. And then lastly, I have this floor here, which is just a bunch of instances of the cube, and it has a little railing so that you don't fall off. And yeah, that's about all the stuff for my demo. I can close it, and it exits with no memory leaks. And then I can also run and release. So release just has a different background color, but otherwise everything else behaves the same. And that's release. And yeah, that's it for my Milestone 2 demo. Thank you.